Let's look at a third question on probability involving tree sketches, and I'm going to make this one a bit more confusing. It's more confusing because it involves a red, yellow and blue coloured beads. So there's three types of coloured beads involved, and this often makes people do the question in a way which makes it more difficult than it need be. For example, let me show you what we've got going on here. A bag contains these beads. A bead is removed at random without replacement, so it's not put back. A second bead is then removed, so we've got two things going on again. Part A, draw a tree sketch. Part B, find the probability of getting two red beads. And Part C, find the probability of not getting a red at all. Okay, so we need to draw a tree sketch of the situation which is going to help us get the answer to these two latter parts B and C. Okay, now if I was drawing a tree sketch here to describe what's going on, and I was looking ahead at what I need to work out from the tree sketch, it would be clear to me that, well, we've got two reds, red and red. We need that obviously involved in the tree sketch, and we find the probability of not getting a red at all. So I've got a probability of not a red again. Not a red. There's no mention of blue, there's no mention of yellow at all in these two questions. So for part A, what I'm going to do is I'm not actually going to draw a tree sketch like this. You could say that the first go out the bag you had blue, a red or a yellow. Three different branches. And then for the second go, a blue, a red or a yellow perhaps. Blue, red, like this, yellow, blue, red, yellow. Now because you've got three colours, you're getting quite a complicated looking tree sketch. But if you look to see what I'm talking about here, I'm only interested in two reds, I'm only interested in not getting a red at all. There's no mention of blues or yellows. So if I was given a free hand as to how I'm going to draw a tree sketch to describe this situation, this is what I would probably do. The good news is, if you're thinking this would not come naturally to you, in these questions in the exam, 99 times out of 100, they actually start the tree sketch for you and ask you to complete it. So you wouldn't probably have to think about this at all. You would just simply carry on, and they would show you the basics of what I'm going to start now for you anyhow. So for example, they would probably do this. They would probably start it off with two branches for you and saying on the first go, you either get a red. Now instead of saying blue or yellow to give three different branches, they're more likely to say to you, let's start off by saying it's red or it's not red, like so. So you don't need red, blue and yellow in a tree sketch such as this. So what I'm saying is that's what my gut reaction would be to do based on part B and part C, because there's only reds mentioned. So red or not red, that's all I'm bothered about. But even easier than that, even if it doesn't cross your mind to do that, I'm saying is they'd probably start that off for you in the exam and you don't have to think about it. So you wouldn't even begin to start drawing blue and yellow branches because they've started off for you like this, red and not red. Okay, and then on the second go, red on the first, what can you get on the second? It's either red or not a red. And likewise, perhaps you got not a red on the first, what can you get on the second? Red or not red on the second go, like so. So this is the second go here, the second go, a bit of a squeeze. I hope you can see it, second go, these here. Now to finish off the tree sketch you need to put the fraction probabilities on each of the branches. So the chances of getting a red, well there's 3 red out of 6 beads, so there's a 3/6 chance of getting a red. Well, there are 3 beads out of the 6 which are not red. There's the 2 yellow and the 1 blue, so there's a 3 out of 6 chance of not getting a red. Notice 3 out of 6 red, 3 out of 6 not red. In total there's 6 out of 6, which obviously means it's a certainty. 6 out of 6 is 1 whole, which in probability terms a 1 whole is a certainty in terms of the fraction scale. So it's either a certainty you get a red or you don't get a red. That's it, it's certain. You either get red or you don't get a red. Okay, second go. without replacement. The first bead is not put back in the bag. So this time there's only going to be 5 beads left in the bag. So for each of these branches, they're all going to be out of 5. Each time it's out of 5, because there's only 5 beads left in the bag. So imagine you've pulled out a red first go, and then you have another go, and we want to pull out another red. Well, looking at this, there was 3 reds initially, so if you pulled out a red to begin with, there's only 2 reds left out of 5 beads left. So there's only 2 out of 5 chances now of getting another red bead. On the other hand, you pull out a red, so that's gone. There's only 5 beads left, and there's only 2 red beads left. But there are still 3 which are not red, the 2 yellow and the 1 blue. So you've got 3 out of 5 which are not red. So 2 out of 5 red, 3 out of 5 not red. Notice 2/5, 3/5 pair together to give 1 whole. It's a certainty. 2/5, 3/5 gives 5/5. So those are the fractions on there. And what you'll find is these fractions are the same as those fractions. You take out, well, something that's not red, okay? You'll take something out which is not red. So that means there's only 5 beads left for the second pull. Okay, well, this one here, having said that they're the same, you're going to be careful because they're actually going to be reversed. So you can't just assume that they're going to be identical every time, top and bottom the same. On the second pull, how many beads are red for the second pull? Well, the first one, we didn't pull out a red bead at all. It was not red. So there's still 3 red beads left for the second go. Out of, and there's only 5 beads left because there's one of them that's gone which wasn't red. It was either blue or yellow. So there's 3 red beads still left out of only 5 beads remaining. Not red, well, that's gone. So how many beads for the second go are left which are not red? Well, there was only 3 in total to begin with, so if one of them's gone, there's only 2 left. So 2 out of 5. So you can see these two fractions are the same value, but they're flipped round. So 3/5, 2/5 are the two fractions like so. Okay, so there is the tree sketch for this situation. I'm going to squeeze in the calculation at the side here, keeping the tree sketch in view. So part B, probability of getting 2 reds. Let's rephrase it. That's the probability of getting a red and then another red. Okay, follow the tree sketch. A red is 3/6. Ignore the ding-dongs again. And in maths is times. And then another red is 2/5. So you get 3/6 times 2/5, like so. 3 times 2 is 6. 6 times 5 is 30. You get the answer 6/30. And 6 over 30 actually cancels to 1 over 5. So you get 1/5 like so. So there's part B. Find the probability of getting 2 reds. Part C. Find the probability of not getting a red at all. Not getting a red at all. Now if you wanted to, you could start talking about not getting a red. You could get a blue and another blue, or a blue and a yellow, or a yellow and a blue, or a yellow and a yellow, or whatever. No, let's just make use of the tree sketch as it stands. Not red and not red is all I'm interested in. So probability of not red and not red. That's all I need to be looking at. And that means you follow the bottom path of the tree sketch. Not red followed by not red. Okay, so 3/6 is not red and is times 2/5 is not red. So you get 3/6 times 2/5. So that's exactly the same calculation as you did for red and red a minute ago. So the chances of you getting 2 reds is exactly the same as the chances of not getting a red at all. So that's going to give you 6/30 again, which cancels to 1/5 again. And there you go, that's the end of this question.